Years ago, as part of the Maquoketa WMA group, there was a subcommittee focused on water quality monitoring, and the goal of the group was to determine how water quality varies throughout the entire watershed. The Maquoketa watershed, where it drains into the Mississippi River, is, I believe, 1,870 square miles. So it's a very large watershed. And we could monitor right where the Maquoketa River enters the Mississippi River. That would tell us what's leaving the entire watershed. But what we know is that throughout the watershed, land use really varies. And there's a number of other factors that impact water quality. So to really understand what's going on throughout the entire watershed, we decided to break the watershed into smaller sub-watersheds. And so we established 45 different sites that have been monitored, not all of them, all 4 years, but most of them have been. And all of the sites were monitored 3 times during the year, because we know that water quality is not static, that it's going to change depending on climate conditions. And so we tried to sample during the months of May, June, and August. With a number of volunteers going out and collecting water samples from their respective sites the same morning. So we're trying to control variables such as climate conditions by all sampling at the same point. So what I'm going to do is just present the results from the 4 years of monitoring that we've done in the Maquoketa watershed. There's a number of individuals, organizations that have partnered with this effort, and then a number of volunteers who have helped with the water monitoring as well. And then, as Aaron indicated, Dave created all of the GIS maps. The data doesn't really mean much until you can visually display it, and maps are a great way to see what's happening throughout the watershed. So as I mentioned, we're monitoring at the sub-watershed scale. And in 2019, we established 34 sites that were monitored 3 times during that year. In 2020, the city of Manchester is interested in establishing a wetland. And so there were 2 additional sites upstream and downstream of where that site will be, to collect some baseline or background data. In 2021, we decided to add 2 additional sites down near the outlet of both the North Fork of the Maquoketa River and then the South Fork of the Maquoketa River down by the city of Maquoketa. And then Lake Delhi was interested in having 7 sites in and around Lake Delhi to get an idea of what the water quality was flowing into Lake Delhi, and then the tributaries entering into the lake as well. So in 2021, there were 45 sites that we monitored. And then in 2022, just this past year, those same 45 sites were monitored again. As I mentioned, we sampled the sites May, June, and August of all years, except in September of 2020, when the derecho hit. We had to postpone the August sampling until September. The parameters that we monitored for remained the same during those 4 years of monitoring. We measured turbidity. That was done by the DNR Fisheries out of Manchester. And then lab samples were collected and sent to Marty St. Clair at College. And he analyzed samples for chloride, sulfate, dissolved reactive phosphorus, nitrate nitrogen, and then E. coli bacteria. And one thing I always like to point out is the way we designed the monitoring for the Maquoketa watershed, because we only sampled 3 times each year, there's no way to really say anything about trends for particular sites in terms of, is the water quality getting better or not? You really need more frequent monitoring, probably on a monthly basis, maybe even more frequently, to really determine, is water quality improving? With our design, what we were trying to do was to be able to look at a spatial area, in this case, the Maquoketa watershed, and identify where there may be higher values occurring for some parameters and where some of the low values are occurring in the watershed as well. So this map shows where the monitoring sites are located. I just want to point out, I don't know if you can see my cursor down here at Maquoketa. We've got the south branch of the Maquoketa River that heads upriver through Monticello on up to Manchester. And then from Maquoketa, we've got the north fork of the Maquoketa River that heads on up towards Dyersville. So you can break down the Maquoketa watershed into two sub-watersheds, the North Fork and the South Fork, and then from there, break it into much smaller sub-watersheds. And that's what these symbols on the map represent. And don't really be concerned with the different types of symbols. Those just identify the different groups that we're out monitoring. But as you can see, we've got a fairly good coverage of sites throughout the whole watershed. And then up here around Lake Delhi, a greater concentration, just given the interest in measuring what was flowing into Lake Delhi. And then at the bottom, sort of the distribution of sites for the different counties that the watershed covers, starting with one site up in Clayton County, extending all the way down to the lower end of the watershed where there are several sites in Jackson County. As I mentioned, 2 years ago, we added 2 sites near the outlet of the North Fork of the Maquoketa River. So this is the city of Maquoketa. Just north of town, we've got the North Fork coming in. So there's a monitoring site here. So this is monitoring what's leaving the North Fork. And then down here, we've got a site on the South Fork. So it's before the 2 branches merge to become the Maquoketa River and then continue on down to the Mississippi River. And then also 2 years ago, the sites that were added around Lake Delhi. This is near Bailey's Ford. So there was a point up right before the Maquoketa River enters Lake Delhi. And then there were 2 small sub-watersheds monitored. And then the other sites, there was a site at the Hartwick Bridge, so a midpoint on Lake Delhi that was monitored. And then below where the dam outlets was an additional site, and then 2 more tributaries here that were monitored. So what happens when we monitor? There are 3 bottles that volunteers have for each site. They'll collect their water samples and then fill the lab bottles, put them on ice. One of the parameters, because we're measuring the dissolved portion of phosphorus, we have to field filter it before the samples are sent off to the lab. So one of these bottles will go to the DNR fish hatchery to be have turbidity measured, and then the other 2 bottles go to College to have lab analyses run. This graph just shows the water level in the Maquoketa River at Maquoketa. So the blue line represents the discharge, how much water is coming down through the watershed. It varies depending on if there's been recent rain or not. The red dots indicate where we sampled. So here are the first 3 sampling events in 2019, 2020, 2021, and then 2022. And the only reason I really include this graph is to illustrate that we were monitoring under varying flow conditions. In fact, the last sampling event in August of 2022, we sort of hit a peak runoff event. We had been very dry during the summer, and then we had some rain that hit the watershed and caused a rise in the river. And so the discharge really does affect what's happening with water quality. So we always keep that in the back of our mind. So what results have we seen? Starting with turbidity. Turbidity is just measuring the ability of light to pass through a water sample. So it's measuring how turbid or difficult it is to see through the water. If the water's clear, it's going to have a very low turbidity. If it's cloudy because of sediment or algae, it's going to have a very high turbidity. There's a number of factors that can affect turbidity. Sediment is probably the primary one. Algae in the water can also cause higher turbidity values and organic matter. And it's measured in what's called NTUs, or nephelometric turbidity units. And just for comparison, statewide average values for turbidity, and this is looking at data collected from a network of 60 sites statewide that are sampled on a monthly basis. The average turbidity is about 16 NTU. So with the map here, what we did is took the 4 years of data and calculated an average value for each site. And then we color-coded the watersheds, the sub-watersheds, to indicate where there were low values of turbidity. So the green sub-watersheds are where we saw some of our lowest values. The yellow sub-watersheds are in the middle average values for the watershed. And then the red are where we are seeing some of our higher values. The upper portion of the watershed, especially the South Fork of the Maquoketa, is where we were seeing our lowest turbidity values. And then farther down in the watershed, both on the South branch of the Maquoketa as well as the North branch, is where we were seeing some of our higher turbidity values. Another way to look at the data is just sort of ranking it from the highest value all the way down to the lowest. And this just shows all 45 sites that were monitored. And just to give you a little idea here, site IDs include, for the most part, the county IDs. So JA8 is a site in Jackson County, JO is a site in Jones County, DU in Dubuque, and so forth. So that gives you an idea of sort of what county the site's located in. But in terms of turbidity, site JA8, which is in Jackson County, Deep Creek, had the highest value, along with the North Fork of the Maquoketa River. So this would be the site down by Maquoketa draining the North Fork. And then Whitewater Creek, one of the sites located in Jones County. So those were the three where we saw our higher turbidity values. And then down on the low end, the two wetland sites up in Delaware County, Fenchel Creek, also located in Delaware County, has some of the lowest turbidity values. Another parameter that we looked at was chloride, and chloride is a component of salt. There's a number of sources of chloride. Chloride tends to be low in Iowa streams and rivers, unless you have point sources contributing, or we also see higher chloride values during the winter months, and that's really associated with road salt runoff. So our monitoring didn't occur during the winter months, so we may be seeing some of the best levels possible because we weren't sampling during the winter months. But overall, chloride levels were pretty low for streams in the Maquoketa watershed. Again, the color coding of the sub-watersheds gives you an idea where some of the lowest chloride values occurred, those being the green sub-watersheds, and then the higher ones occurring are the red watersheds. So looking at this map, the higher values tended to occur with some of those sub-watersheds in the North Fork of the Maquoketa watershed. And the Fenchel Creek up here also had some higher values. But overall, the values really weren't that high compared to what we've seen with streams statewide. And then again, we can rank values from highest to lowest. What we found was that the two sites near the proposed wetland up in Manchester had the higher values. And this maybe isn't surprising based on some other monitoring that I've been involved with. Urban sites tend to have higher chloride levels than rural sites, and that has to do with if you think about, there's more concrete, more sidewalk, more application of salt occurring in urban areas and rural areas, and eventually that can leach into nearby streams. Sulfate is the third parameter that we looked at. It tends to be naturally occurring in minerals, soils, and rocks in Iowa. There's a definite geographic distribution of sulfate statewide. We tend to see higher levels in the northwest part of Iowa, and that has to do with the type of soils that occur up there compared to elsewhere in Iowa. Statewide average for sulfate is 34 milligrams per liter. And if we look at our map of where the sulfate concentrations occurred, if you look at our highest average value, it's only 30. So overall, the sulfate levels for the Maquoketa watershed were quite low compared to what we see statewide. Higher values within the Maquoketa watershed, again up here on the sort of headwaters of the North Fork of the Maquoketa, and then Plum Creek, this subwatershed, and a couple up here at the headwaters of the South Branch of the Maquoketa watershed. And again, ranking values from the highest to lowest. Again, overall, the levels are below what we typically see as average sulfate levels statewide. So really nothing of concern with the results that we were seeing here. And you might ask, you know, if we're not seeing anything, why do we monitor for this parameter? And for the lab at COLI, they sort of run a ion screen. And so sulfate is one of the parameters that they'll report out for us. So it's useful to know that the levels are low. Now getting into sort of the nutrients, which are some of the more the parameters of greater interest. We'll look at phosphorus and then nitrogen. First of all, looking at phosphorus. Phosphorus is necessary for plants and animals. Levels tend to be low in Iowa, although there are some areas where we do see elevated phosphorus concentrations. The concern with phosphorus is if there's too much in streams, it can result in increased plant growth and cause algal blooms. And as the algae dies, there's oxygen that gets consumed and pulled out of the water. And with lower oxygen levels, that can have a negative impact on fish and aquatic life in the water body. Statewide stream average for phosphorus tends to be less than 0.1 milligram per liter. So looking at the distribution of phosphorus, and this is looking at the dissolved phosphorus or bioavailable phosphorus. And as I had indicated, statewide, our average concentration or median value tends to be 0.1. And what we're starting with for sites in the Maquoketa watershed is 0.13. So we're already above that statewide average. And so sites in the Maquoketa watershed tended to have higher phosphorus levels than what we see in streams statewide. And there's a definite pattern here. You can see here, this is the North Fork of the Maquoketa watershed, and the subwatersheds draining into it tended to have our higher concentrations of phosphorus. The exception is here, Farm Creek, which drains into the South Fork. And then there was one site up here, one of the tributary sites to Lake Delhi, that had some elevated phosphorus as well. And again, ranking sites from highest to lowest. John Creek up in Dubuque County, and then the North Fork of the Maquoketa River in Dubuque County as well. These sites have been monitored all 4 years, and all 4 years tended to fall on the upper end of phosphorus concentrations for the sites monitored. And then down on the lower end, actually the Maquoketa River down at Maquoketa had some of the lower concentrations. And then the Maquoketa River downstream of the dam at Lake Delhi had the lowest concentration of sites monitored. But keep in mind, some of these sites were only monitored 2 years versus 4 years. The other nutrient that we monitored for was nitrate nitrogen. Again, nitrogen is essential for plant growth. There's different forms of nitrogen. We monitored for the nitrate nitrogen. There's a number of sources where the nitrogen can come from. What we know is that nitrate concentrations vary depending on the time of year. We typically see higher levels late spring, early summer, and that has to do with the timing of when fertilizers being applied and then timely rains. Nitrate's water soluble, so if you've got the source of nitrogen available on the landscape and then water to sort of mobilize it, that nitrate can readily move to nearby streams. Our statewide average for nitrate is a little over 5 milligrams per liter. I included the drinking water standard, which is 10 milligrams per liter, and that's solely for perspective. None of these streams that we monitor are used for drinking water, and so that standard does not apply. So the statewide stream average is 5.5 milligrams per liter. And this map shows the average nitrate concentration throughout the watershed. And there's a definite pattern in the water quality. Our average concentrations ranged from 3.1 milligrams per liter up to 12.5. The lower end of both the south branch of the Maquoketa watershed and the north fork of the Maquoketa watershed is where we saw our lower concentrations of nitrate, and then the higher concentrations occurring more up in the headwater areas, actually a number of the sub-watersheds along the south fork of the Maquoketa watershed, and a few scattered in other areas as well, including Prairie Creek here. Again, if we rank sites from the highest average concentration of nitrate during the 4 years down to the lowest, our highest sites included Spring Branch up in Delaware County, and Spring Branch is what feeds the hatchery at Manchester, and then Plum Creek also in Delaware County had some of the higher values. And then some of the lower sites were the North Fork of the Maquoketa at Maquoketa, and then several of the sites in Jackson County as well. And then the last parameter that we monitored was E. coli bacteria. And E. coli bacteria is what we call an indicator bacteria. It indicates that there's a relatively fresh source of fecal matter from a warm-blooded organism in the water. It's not going to distinguish where that bacteria is coming from. Is it livestock? Is it human waste? Is it wildlife, human, livestock? It's not going to tell us that. It's just indicating that there is that bacteria present in the water. And bacteria levels can be extremely variable. There's a number of factors that impact them, rainfall being one, time of year, sources that might be available on the landscape. And we measure bacteria in what we call colony forming units per 100 milliliters, or CFU per 100 milliliters. And Iowa does have some statewide standards based on how the stream is designated for use, whether it's primary contact, recreational use, children's contact, or secondary contact. For perspective, the statewide stream average for bacteria is 120. And if we look at the Maquoketa watershed, our values, average values for the 4 years ranged from 31 to over 14,000 CFUs. So we had some sites that had some pretty high levels, and the sites were really scattered. There were several sites in the subwatershed of the North Fork, but we also had some sites up here near the headwaters of the Maquoketa, the south branch as well. So there wasn't any real distinct pattern of where the high values were occurring. But for the Maquoketa, at Maquoketa, and then the North Fork at Maquoketa, we had some of the lower values occurring in terms of what was leaving the entire watersheds. And again, we can look at the data from where the high values were occurring. LD1 refers to a site, one of the tributary sites to Lake Delhi, and then Plum Creek consistently was having some of the higher values that we saw during the 4 years as well. And then down at the lower end, there are a couple of the sites around Lake Delhi. Downstream of the dam had one of the lower values, and then the Maquoketa River at the Hartwick Bridge also had the lowest value actually that was monitored during the 4 years. So that gives you an idea of how water quality varied throughout the watershed. What I want to do next is compare the Maquoketa data to what we see in streams statewide. So during the time that we were doing the monitoring, the Iowa Department of Natural Resources was monitoring 60 rivers across Iowa. And this is part of a network that they've been monitoring on a monthly basis since 2000. So those sites have a lot of data. But what I want to do is just compare the results from those 60 statewide sites to what we saw for the Maquoketa watershed to give you an idea of are the results high or low compared to other parts of Iowa. And I'm going to show some box plots, and really the only thing, two things that I want you to focus on is this middle line in the box represents the average or median value. So if you were to rank the data from low to high, what value falls right in the middle? And then the size of this box, if the box is small, it tells us that the data don't really have a lot of variability. The results are very similar. Whereas if the box is bigger, there's a lot more variability in the data. So first of all, if you look at the right half of this graph, this is the Maquoketa watershed data that was collected. So here are the results for 2019, 2020, 2021, and 2022. And then during the same time, those same 3 months, here's the data statewide. And so what we saw is that the results were pretty similar. If you especially look at the median values, there isn't really a lot of difference when you compare 2019 for streams statewide to what we were seeing for the Maquoketa watershed. And again, the boxes are not very big, so there wasn't a lot of variability. You're going to have some of these dots or outliers where there are some higher values that occurred, but overall, there wasn't much difference between these two data sets for turbidity. If we look at chloride, what you'll notice is the statewide median value is 21, and most of the results for the Maquoketa watershed fell below the statewide average. And then when you compare chloride to the statewide data, chloride for the Maquoketa watershed sites tended to be lower than what we were seeing for streams statewide. Next, looking at sulfate, this is where you really see a big difference, where the sulfate results, we didn't really see much variability for the Maquoketa sites. These boxes are really small, and from 1 year to the next, the average value or median value, I should say, doesn't really change much. Whereas statewide, there's a greater variability in the sulfate levels that we see, and some pretty high numbers. These are primarily for sites monitored up in the northwest part of Iowa. And then getting to the parameters where we really start to see some differences. This is looking at the dissolved reactive phosphorus. Again, on the right-hand side, this is the data from the Maquoketa watershed. Our statewide median value tends to be less than the 0.1 milligram per liter, so that's the red dashed line. And all of our median values for the 4 years of monitoring fell above that. And then comparing it to streams statewide, there's a noticeable difference where there's a lot more variability in the phosphorus concentrations for the Maquoketa than what we see for that network of streams statewide. And then looking at nitrate, again, the 5.5 milligrams per liter, the red dashed line represents the median value based on 20 years of monitoring streams statewide. And again, our median values for the Maquoketa sites pretty much all fell above that median value. And then overall, the boxes are a bit bigger. There's more variability in the concentrations that occurred for the Maquoketa. And the Maquoketa sites were had higher concentrations for nitrate than what we saw for the streams statewide. And then the last parameter, the E. coli bacteria. This is on a log scale, so there's quite an increase in numbers here. Again, the statewide median is 120. Pretty much most of the sites had values above the statewide median. And when you compare these 4 boxes to these 4, the E. coli bacteria levels were higher for the Maquoketa watershed than what we saw with streams statewide during the same time period. And then this is the eye test, and I don't expect you, to be able to read this. But what we can do is organize all 45 sites, and then the numbers represent the median value for the different parameters. Sorry about that. And so on the left, and I can't even see my, these at the top are the different parameters going across the top, and then the median value for each site. The blue highlighted cells indicate where the higher concentrations were occurring, and then the orange represents the lower concentrations for each site. So if we zoom in, this is looking at where the higher concentrations were occurring. And it's not as though a few sites where we're seeing high phosphorus concentrations, nitrate and E. coli. It was a lot more variable. So if you take, for example, LD5 is one of the tributary sites into Lake Delhi. It had some of the higher nitrate and higher bacteria levels, but then the phosphorus concentrations weren't as high as some levels that we saw elsewhere in the watershed. So this just gives you an idea of how sites compare to one another. And then also taking a subset of the sites and then just looking, these are the sites where we saw our lower concentrations occurring. So again, it's not as though a few sites had all of the low values occurring for all parameters that we monitored. And in this case, I didn't include sulfate and chloride since those two we weren't really seeing very high levels occurring. So I just focused on the phosphorus, nitrate, bacteria, and then turbidity values. So in terms of chloride and sulfate concentrations, for the Maquoketa watershed, levels tended to be low and really didn't show much variability in concentration. Turbidity levels tended to be higher for tributaries feeding into the North Fork and southern portion of the South Fork of the Maquoketa River. The dissolved reactive phosphorus concentration were highest for tributaries in the upper portion of the North Fork of the Maquoketa River. And then John Creek, site DU3, had some of the highest concentrations during the 4 years of monitoring. And then for nitrate concentrations, we were seeing higher values occurring in the upper portions of both the North Fork subwatershed and the South Fork subwatershed as well. And the Spring Branch, which is a site in Delaware County, had the highest overall nitrate concentration for the 4 years of monitoring. And then bacteria levels, the high levels were really scattered throughout the watershed. There really wasn't sort of a particular area that consistently was showing the highest bacteria levels for the monitoring period. When we compare the Maquoketa data to streams statewide, the Maquoketa watershed tended to have higher nitrate, nitrogen, E. coli bacteria, and phosphorus concentrations compared to streams statewide. The Maquoketa was lower, had lower chloride and sulfate levels. And then the turbidity levels were similar for the Maquoketa to what we were seeing in streams statewide. And I believe that's it. If anybody has any questions at all.
Yeah, feel free to unmute yourselves and ask any questions that you may have. Thank you, Lynette.
This is Carol. So what are our next steps?
That's a very good question. So after 4 years of monitoring, I think we have an idea of where some of the higher levels are occurring. And so I think it's really a decision the Maquoketa WMA board needs to make in terms of, do they want to start prioritizing some watershed efforts to focus on some of these areas? Do we want to adjust the monitoring to focus on some of these areas and collect more frequent data? I think it's up in the air right now as to what we'll be doing next. It's, the board has had the data presented, but we haven't taken any next steps at this point. And Erin, you can chime in there.
That was kind of what we planned to do, is reevaluate. We kept for the 4th year, we kept the same locations, but now we really do need to kind of hone in on some of those locations that have higher nutrient levels and see if we can maybe ramp up the monitoring and kind of get some more data for those areas, more frequent data.
More frequent, and then in more areas too?
Yes. And I would love to see more locations being monitored. That's kind of the plan for this winter, is reevaluate, kind of figure out a plan if we need more volunteers, how we're going to make that happen, if we need test strips, what we should do for this next season.
Okay. I have another quick question too. I'm not sure how valid it is, but just curious, we talk about all the different nutrients and how they're getting into the Mississippi, and then they're going down to the Gulf and creating the dead zone. And maybe I'm not understanding, and maybe the averages are still super high, even though when you compare them across the state, they're lower in some instances. But when you look at the southern end of the watershed, particularly down by Maquoketa, we have high nitrogen and high phosphorus and high E. coli in the North Fork and everything. And then by the time it gets down to Maquoketa, a lot of that stuff is less, or maybe I'm not reading the information correct. Does that make sense?
Right. So looking at the maps, we were seeing some of the higher values farther up in the watershed. But something to keep in mind too is we didn't really look, concentration is one way to evaluate water quality, but you can also look at loads. So when you factor in how much water is moving down, that can give you an idea of tons of sediment that might be leaving the watershed. So the numbers might be appear different if we had more frequent monitoring to determine what was really leaving the watershed down there. And the DNR does, as part of their 60 sites statewide, they do monitor the North Fork, and then they also have a site on the South Fork. and then one downstream of where the North and South Fork join. So there's actually 3 sites monitored on a monthly basis down there.
Okay.
Are there any other questions? That was a good question. I mean, it is obvious that a lot of those levels are different at the headwaters of the watershed versus downstream. So it's important to notice that.
I guess I just have one more question. Is it possible to share this with more people? I mean, you put something like this in the newspaper, no one's going to read it because they won't understand it unless it's explained to them, I guess, unless it can be, for lack of better words, dumbed down to maybe just a real high summary and just put into newspapers or just reported on so that more and more people know what's actually going on and that this is happening and what you guys are finding.
Yeah, I think that's a good idea to have it in the newspapers. That's kind of the reason behind this presentation, is to also record it and then have it on our website. So it is more widely available. I'm going to convert this to add it to our YouTube channel so it can be shared. But I don't know, Lynette, is there a way to kind of create, we could maybe work together to create something
Right.
that could be shared, you know, in newspapers, and we could send it out to the press about this information.
I think it would just be good for people at least to hear it or see it, read it. Then they're going to start asking questions, and then I think more things can happen, you know, because they're going to right away be, well, it's not my fault, or, you know, all that stuff will happen. But those questions are going to come up, and I think it's good for those conversations to happen, I guess. Yeah,
I completely agree. And we are working with Dubuque County Watersheds, their urban watershed coordinator. He and I share data back and forth. So they're hopefully one day going to have some sort of data available to the public that, you know, water quality data. And so we're working together to share all of our data with them, so then they can have that available whenever that time comes. Kyle, did you have a question?
Yeah, once you have kind of a Reader's Digest condensed version of your data, could it be shared with our politicians, Steve Bradley, Lee Hine? Lee, I believe, is a chairman of an ag committee, and I feel there's a very close tie between some of the issues we're having with water and agriculture, and it'd be nice for him to weigh in on this.
Yes, I agree. We invited, for our October 26th board meeting that we had, I invited a lot of the representatives and legislative members to that. And we had a few of the candidates, but we didn't have those two folks that you mentioned. So it would be nice to be able to have, once we have this as a YouTube video, then we can share that with them as well. But also, like, the version that we're going to work together to maybe create, where has just an outline of the data. I think that's a great idea. Thank you.
Aaron, this is Mike, private
Mike.
from Dubuque County. My question to you is there a way of getting this to the commissioners in each district, and then actually when the commissioners get together, actually have the supervisors meet with them, and then actually do the Zoom meeting to them, show them what it is? that way they can communicate with each other. I know we got a really good working relation with our supervisors, but that's way they can kind of, look at this stuff and see where we're gonna be in their county. And I think they should probably be aware of what's going on, because if we're not going to, if the district's gonna do something, well, the supervisors should be actively involved in what the district does too.
Yeah,
And
I think
maybe
that's a great idea. We haven't shared this with them, yet, but I think we should, since we have this recording, for sure, plan to do that.
I actually gave it to the other commissioners, and they had a lot of questions. So that's one thing. If you can get this to me right away, I could get it out to each one of them, because they want to know what it's about. See what the Butte
Okay.
County is doing. We're very active in that too. So
Are you looking for the recording, or you want all the slides as well, and just kind of
Well,
everything?
I think the recording probably will answer that. They got the slides would be fine, but the recording would probably be best, because it explains to them why we're doing which for each parameter that's out there. And I
Right.
think that's the question that they have.
That's why I wanted Lynette to do this, because she's so good at explaining all of the data and everything. So
Hi,
yeah,
Lynette.
I will make sure to get this figured out tomorrow and send it out and have it up on our website. And Mike, I can send it to you, a link to you as well.
Okay, I will get that to the commissioner center as quick as I can.
Okay, great.
Thank you.
Wonderful. Thank
Thank
you.
you.
Thanks for joining us. Well, if there aren't any other questions, Kyle, you still have your hand up, but I guess that's from the first question. But are there any other questions before we say goodbye?
Hey, Aaron, this is Dave.
Hey, Dave.
Hey, just wanted to say thank you to you and Lynette for putting us on tonight, and all your work that you do with the sampling and getting the results, and getting all the volunteers, all the supplies of the volunteers and the samples of the college. We sure appreciate that, and it's really helpful information for us. So thanks again.
Well, we thank you for making the maps and all the work that you do to make it visually. We understand what it shows because of the colors that the maps show. So you do a great job with that. So thank you. Okay. Lynette, do you have anything else to add?
I do not.
Okay. Thank you so much for doing this and creating this presentation so we can all understand all of what it all means.
You're welcome.
Aaron, if I could, just one more thing.
Sure.
Like Lynette and Aaron said earlier too, the water monitoring group is planning to get together this winter. We don't have a date picked out yet, and just discuss our, what do we want to do next, how we want to change the sampling, and make recommendations to the WMA board with those. So if anybody would like to be involved with that or provide input, we'd sure appreciate it. Just let us know and we'll make sure to get you the contact information.
That's great. Thanks, Dave. I failed to mention that, but yes, we are always looking for more support and more interest. So definitely if you're interested in joining and being part of that committee and or other, just, more involved with the WMA itself, please reach out. But with that, I think I'm gonna stop recording.